Okay, we're going to go ahead and get started here, folks. First of all, on behalf of InkyTel, I'd like to welcome everyone to our Government Platform Accelerator webinar. Today, we're going to be talking about best practices to accelerate the ATO process. My name is Barry LaFew. I'm the Vice President of IQT's Government Platform Accelerator. And our platform accelerator is really designed to be a resource for portfolio firms to help you on your journey to build and grow your government business. And in addition to these webinars, we have online training, series of white papers, and then we do a lot of one-on-one strategy meetings with our portfolio firms. And one thing to mention, this here is being provided courtesy of InkyTel's legal department. But in today's webinar, there's no government resources or funding that was used for our webinar today. And please take this advice as advice, but it's not meant to be, specific recommendations for processes to take. Okay, so with that, I'd like to introduce our speakers today. We have really two fantastic speakers, both from ChainGuard. First, we have Eric Bannon. Eric is a senior solutions engineer with really deep experience in the whole compliance and security and automation space. And joining Eric today is Natalie Summersall. Natalie is also a principal solutions engineer at ChainGuard, and Natalie has extensive experience working with government customers and helping to facilitate and enable the ATO process. So we're looking forward to today's discussion. Welcome, Eric and Natalie. And to kind of set the stage here, right, I'm sure all of you attending today are familiar with the authority to operate process. But from my perspective, it's really important, as a software or SaaS provider, getting an ATO really opens up your ability to scale and enable the flow of revenue, right? Because to get additional users, that's what really typically enables you to grow your business. And so getting that ATO is really essential to accelerating and building your revenue. And then from the government's perspective, having a software product have an ATO that really enables them speed to address mission. So with that, I'd like to welcome Natalie and Eric. They have a brief presentation to kind of share, to talk about what the ATO process is all about. Over to you, Eric and Natalie.
Absolutely. Thank you so much. So I could not do anywhere near as good of a job at introduction. So thank you so much, Barry. I'm going to go ahead and check. Can everyone see my slides?
Yes.
All right, perfect. You always ask, and then you try and you try and you try, and that's it's always fun. So here's what we're actually kind of talking through today as far as the software that goes into the software that you're building. 10 years ago, when I was first starting to build a software factory, when I was in practice, this ratio was supposed to be 80-20 or 90-10 or 70-30 or 95-5. I'm not sure it truly matters which percentage, but the vast percentage of the code that you are asking the government to accept risk on in your ATO is not code that you wrote. It is not code that you're responsible for. It is code that you are picking up off the internet. I like to use gas station sushi, but I think gas stations have a much higher standard of what you can publish in your refrigerator tray than what you can put on the internet. And the truth is that 99.99999% of open source maintainers are fabulous and are not at all malicious and are not at all, looking at their projects as anything other than their, special, amazing project. But that doesn't mean that there's not some level of risk associated with it. And more importantly, your engineers can't know everything about each of these projects. Your engineers may be the world's experts in solving this one mission problem, but maybe they're not mission experts on memory key value stores or in a particular programming language or a particular application. And software supply chain attacks are on the rise. So there was a very, very popular formatter for a very, very popular language, JavaScript, that was compromised for a few hours earlier this week. Like, this is becoming a great attack vector because so many things are making its way into your software that you maybe don't know about. And that is the problem that we've set out to solve. And here's kind of the high level of how we like to think about that software dependency. Eric, did you want to jump in on this slide, or did you want me to jump in a little bit more?
Yeah, I can. Happy to. Thanks, Natalie. Yeah, I think there's a couple different things, right? When we're thinking about FedRAMP and ATO, provenance is extremely important. Where this source code is coming from, the build system integrity, right? So she used, the gas station sushi analogy. The other one we like to use is like if you're pulling libraries from open source, if you're pulling upstream Docker images, for example, uh, it's kind of like plugging a USB stick from the sidewalk into your machine and downloading that. So there's not a lot of transparency into the build systems that are used upstream. There's not a lot of visibility into that. And then also from a vulnerability standpoint, a lot of organizations, I think, are at different levels of their vulnerability management program. So how do you not only get transparency into the source and where you're getting things from, but then I think once you're building with those things and you're putting your code on those open source images and dependencies, how do you scan for them? How do you have systems and processes in place within your build systems and your pipelines to effectively detect when something is vulnerable? And then the whole great exercise of prioritizing risk and false positives and where you're impacted and all these things uh, become, I think, very exponential. So all the way from the source to when it lands in your environment to when you're going into production, I think for ATO specifically, uh, visibility is like the number one requirement before anything, and how you're addressing that becomes the next level of real challenge, right? How are you resolving these vulnerabilities or these build system risks? How are you resolving the things you're introducing into your environment? Well, the only way you can do that is if you've got a good capture on this problem in your organization and where open source is being used. So that's the only thing I would add to that.
Absolutely. And this is how those attacks happen, and understanding how those attacks happen and how that risk is truly makes its way into your organization is really the point of how we'd like to think about open source security and safety here. So that is what we do. We do not in any way, shape, or form want to change the code that you are writing. All we are is a provider of safe, trusted builds of open source software.
Hmm.
What we're
So,
known
in,
for, oh, go ahead.
yeah. So, in essence, Natalie, you're able to take open source software off the internet and then validate it and ensure that it's secure before it's used in a product that's being delivered to the government for an ATO. Is that correct?
Absolutely. That
That's
is what we do.
that's very cool.
Um, and we're known for this zero CVE kind of magic, and there's no magic involved, actually. There really is no secret sauce to having such a low CVE count. It's hard work done well every single day.
Right. And hey, Natalie, what is a CVE? Maybe some folks in the audience, that might be a
Yeah,
new term.
absolutely. So that is a common vulnerability enumeration. So when you find a flaw in a software, anything from security to perhaps something that would compromise the availability of a system, or simply just a logic bug that could in some way impact security. That goes through a process of saying, hey, Eric, your lovely open source software, like, hey, I found this bug. Can you fix it? I've opened a CVE with NIST. Actually, NIST operates the main database, but not every CVE goes through that. And that process of fixing and finding goes on parallel to the process of a scanner, something like Gripe or Trivy, finding that. So FedRAMP, among many other standards, requires you to fix and manage your vulnerabilities on a cadence of some sort. So FedRAMP is 30, 60, 90. There's some new language that possibly will tighten that up for how many days you have to fix different vulnerabilities at different criticalities. And of course, if you are getting an ATO through the DoD or other government customers, like they might have their own standards as well for risk management to that mission.
Great, great. Thank you.
Absolutely. Eric, do you want to jump in here?
Yeah, I think just adding some color and kind of the atmosphere and the environment. If anyone had read about like the MITRE stuff and when they had kind of reorganized how they manage like NVD and things like that, it's no longer really a risk. But I want to stress the importance of like CVE disclosure involves many different layers from the people who initially find them to the people that assign risk scores, and it's not a perfect science. So like what ends up coming through your scanner, you still have to analyze, is it a false positive? There's plenty of red herrings in there. There's a lot of real stuff and there's a lot of not real stuff. So I think like just stressing the noise versus signal problem is very challenging for organizations who are going for ATO, because trying to answer the question what's real or what isn't real coming through those layers of analysis to where it ends up to you is traditionally pretty difficult. So if you're building secure from the beginning and you're eliminating that, your signal ratio increases. You eliminate a lot of the stuff you can't control, both real and fake, right? And so like I like the number 0 because it means you don't have to have the conversation on is it real or fake. It's just not there in your software, right? And I like to make that point because it's oversimplified, but
Great. Thanks.
So I'm here to tell you how to do the thing. There's no magic, but what you do need to do is you can't own the risk for something you don't own. So we build from source. That's how we get to 0 CVEs. Is we build everything every single day. We triage findings. We issue advisories. We push new images. And by keeping small updates quickly and aggressively bumping those dependencies, the things that software needs forward, we're able to maintain a very, very low risk posture. And then the other side of that risk is, well, what if an update breaks something? We are equally aggressive in regression testing. So testing and validating and making sure that didn't actually break anything. So it is one of those problems that is very, very easy to do at machine scale and automate, and very, very difficult to do on human scale. But we do this all the way down. We bootstrapped a compiler, and everything up from there is what we have built from source. And the reason that we did this is depth provides defense. It allows for everyone to understand the risk, and that knowledge is what mitigates the uncertainty, that depth of understanding of your dependency tree. And we've been talking about software bill of materials for a very, very long time as the industry. Like this is probably a 10-year-old graphic from NTIA. But that doesn't mean that we've always had a great quality of SBOMs as an industry. That doesn't mean we've always been able to really understand what you're running. So in order to understand what you're running, you should build and understand it yourself. But only supported open source. And what I mean by supported is, please, end of life means end of life. Going back to the gas station sushi, if the power goes out, you probably don't want to eat that sushi. Please don't ask about the security of Python 2. It has been end of life for over 5 years. And being able to support a mission securely means integrating and understanding those security patches and moving forward with them. With safe compiler options. So one of the things that you'll find pretty quickly in the offensive world is memory safety is a great thing to talk about, and it's not always a great thing in practice. It's not really widely used in practice. So there's a lot of executive orders and discussions around, hey, we should move to a memory safe language like Rust. It's great. However, not everyone is going to immediately rewrite all software that you rely on. That's just not how life works. There's no magic, ability to say there's more than 24 hours in a day. However, what you can do is provide a ton of additional safety by doing things like removing your debug symbols, by mitigating the risk of memory leaks and memory layout problems. And this has been enumerated in great length. And that is how we like to build our software, is we recompile that with safer options because we actually own the compile step. And all builds should be both declarative and reproducible. The way that we do this is it's all in YAML. It's all like really plain text and easy to read. However, there's 100 ways to accomplish this task. The way that we like to do that is check that everything that you bring in has a cryptographic hash, an identifier that says this is what I'm expecting to download. It hasn't been tampered with in transit. And that these are all of the dependencies that are needed for this to run, or needed for this to build. And these are all of the tests that are needed. By declaring this, by writing this out as code, we're able to have multiple engineers review that build. And each build, same bits in, same bits out every single time. And then we reproduce it, or we assemble it reproducibly as well. And what I mean by this is, when I was first starting out in the federal world, this was right at the rise of this really cool new technology called containers. This was before Docker made it easily accessible and usable. And I was told that I could take my gnarly build files and my gnarly Jenkins build scripts and all of these other things that went into taking this code and making an artifact to deliver to the mission. And I could remove that. I could build something and it would be the exact same thing everywhere that mission needed it to be. Turned out that was only kind of sort of true, because my container build also had steps that varied based on when I ran it or what machine I ran it on. So I would copy things in, I would set environment variables, I would do all of this fun stuff. But if I built the same container and Eric built the exact same container, there was no guarantee that we'd get the exact same bits. And assembling that container is how we do things instead of running a Docker build. So thousands and thousands of containers every day, not a single Docker file to be found here.
And quick question there on that previous slide. Some of those acronyms, APKO and APK, yep. What are those, Natalie?
Yeah, so we build container images, and those container images are made up of a collection of other bits of software. So in this case, this is our main package up here at the top. I don't know if I'm drawing on the screen here or not. And in order for that to run, I need all of this bits of software down here. So that 1,400 or so images that we build, there's actually probably about 100 times that in packages that we build. So those APKs are packages, and then we have an assembler that does this. And these are all open source projects that anyone can check our homework with.
Yeah, cool. Yeah, and I think just from an industry standpoint, the important thing to mention here is we're not a derivative of Ubuntu, Debian, anything, Red Hat. The reason we don't do that and we build from source is because in order to solve the problem of secure open source and zero vulnerabilities, you have to do it all the way at the raw ingredients. And so ChainGuard has its own OS, or an undistro, if you will, but the factory produces all that source code into its own packages, just like a normal package manager you would use for Debian or something else. And then we build those into images. Then we do the tests on the images to deliver that to the organizations within ATO. So some of the things we'll get into in a little bit too is we deliver FIPS enabled versions of those images. So, if you're using a node image from Docker Hub, or you're using an open source project like Prometheus or Grafana, even harder to include FIPS in. We have FIPS versions of that will pass the cryptography requirements for ATO. And then ChainGuard also has an SLA of 7 days to resolve critical vulnerabilities and 14 days for high, medium, and low vulnerabilities. So for things like Kanban and POAMs and things that you have to do to actually document what you're doing to address them, effectively, because you're sourcing your images from us, the configuration and the maintenance and the ongoing SLA of resolution to security risk and vulnerabilities falls on us, which makes it a lot easier to enter these markets for ATO, because you don't need to build this from scratch and do everything that Natalie's showing. So that last file is just an example of how we package things securely at the source, but it's just a normal APK package that gets delivered in the images you would consume.
Great, thanks. I'm learning a lot today. This is terrific.
That's what we're here for, Barry.
Right.
And it turns out when you own the entire build process end to end, all of the regulatory needs around a software bill of materials and all of the risk management of understanding who and where and all of the things that went into the software you're delivering is pretty easy. So we like to think of it as like farm to table open source software, but it really is. Like, we own that entire supply chain, and because we do, some of the really, really hard technical problems become really pretty straightforward. So all of our images have a software bill of materials. We didn't really think that this was a great competitive differentiator or particularly difficult to do, because we owned that whole process to begin with. So, bit of a nerd here. I know this quote from Sid Meier's Civilization. Perfection is achieved not when there's nothing more to add, but there's nothing left to take away. Turns out this guy is actually really, really cool, and he led a fantastically interesting life. He was a pilot for France in World War II. He wrote children's books after the war. He did all around the world type of adventures and wrote about it. And I know him from a video game. But the thing is, when you do things the right way, it does make life a little easier. And when you pull an open source package from Docker Hub, this is the comparison here, the number of things in that image can be a bit of a problem to understand what you're trying to ship and what risk that really presents to the mission. So you can see Python and Ruby and Node, these have 400 different dependencies in that piece of software. And ours are so much lower because we own that whole process, and only the things needed for Python, Ruby, or Node go into that image. And that's how you start and stay more secure. So this is that same vulnerability presentation data that we talked about earlier. So when you're trying to go for an ATO, or you're trying to work your way through some sort of risk management, get your certificate to field, all of these questions revolve around what risk are you presenting to the government customer. And in this case, this is, on the right, that is 200 different things that you need to know, like, hey, that only applies to desktops that also have this thing, or this only applies to servers that are running this version of Windows, or this only applies to, if you also have these other things going on. But that's just one piece of your entire application stack. You're likely going to have several of these, each with 200 things. And understanding and knowing what is and isn't a risk to your mission can be really hard. I'm going to pick on Jenkins here because regardless of the application, stack, or language, this logic of minimalism and owning that supply chain still holds. So you pull Jenkins latest, you build from source Jenkins latest. The exact same piece of software has different levels of vulnerabilities in it. And the benefits keep adding up for air gap environments. So as Barry mentioned, I work with public sector directly, and a lot of the mission edge, the tactical edge, is all about, hey, this is great, but I don't know if this thing is going to be connected to the internet all the time. I don't know if this thing will be connected ever. What does that look like at a 6-month disconnection? So if you pull the exact same image, and in this case, this is a version of Python, I think, 6 months ago, there will be 8 additional things that you will need to understand and remedy 6 months from now. For this one example, this chart kind of keeps iterating itself across any particular piece of software. But if you'd had that upstream alternative, like there's 195 different risks that you're going to need to understand in that ATO process. And smaller too. So, Python, Node, Redis, Postgres. When you only bundle the things that are needed for that one task to run, those end up being so much smaller.
And Natalie, would that result then in the software that's being delivered being more efficient, using less resources then? Yeah.
Yes. This is doubly true for trying to run on the tactical edge where you are resource constrained.
Mm-hmm. Interesting. Okay.
Eric, do you want to jump in here?
Sure. I didn't know if just looking at the time, if we wanted to move into some questions or anything like that, or what do you guys think?
We have a few more minutes, Eric, before we go to questions. If there's some additional things you'd like to cover, and then I'll mention to the attendees we'll be taking questions through the chat. So if you want to put some questions in the chat, I'll moderate those and then have Natalie and Eric address those. But let's go a few more minutes, Eric, and then we'll shift to questions.
Sounds great to me. If you want to, do you want to flip the slides for me, or do you want me to share screen now?
I can do that. Look, okay. I had to have removal of the small furry kittens. They were starting to chew the cables. I'm surprised.
No worries. Yeah. So in the end of the day, there's a couple aspects I think for ATO that we're gonna talk about here in the Q&A and things. And obviously the boundary includes a lot of things. Chain guard will not apply to all of them, but there are very specific requirements, especially if you're running containers in your environment. Obviously, virtual machines are one thing, but if you're running Docker, if you're running Kubernetes and EKS and Google, your own managed Kubernetes or anything like that, chances are your developers are pulling images from Docker Hub. They are introducing those into the environments that you're targeting for ATO. And what we want to do is we want to provide developers with an easy way to continue doing what they're doing on the equivalent things they need, right? If it's Node, Java, Python, if it's a third-party open source project, but doing all the things that we talked about, right? So think of it as a repository or a catalog of images that meet these requirements. And the main thing is they're minimal, they're 0 to low CVEs, they're hardened and compiled with the best practices and the things that Natalie went through, SBOMs, all those things that you need. But two things I like to focus on is FIPS configuration as well as how you address vulnerabilities. So here's an example of some of the impact levels that you might be going through for like moderate, high, or IL, the Rev 5 controls that this would relate to. And these are things that you'll need to meet within the container environment if you're using Docker images, if you're using Kubernetes, if you're deploying applications. in that way. Typically, what you're going to see is that you'll have to have a plan of action to address CVEs. Our system immediately provides a 7-day SLA on the CVEs, so you can think of us as kind of the cook in the kitchen. We're going to fix the meal and deliver it to your registry for you to use. You simply consume it, and the developers use a secure configuration that will pass the sniff test for this. And then for things that require FIPS, it's very challenging for organizations because you have to do two things with FedRAMP. One is you have to show that a correct FIPS module is in use for either OpenSSL or Bouncy Castle. It needs to have an associated CMVP to it. It needs to be validated by a NIST lab. And then the second more important part is you have to show that it's in use, right? So some of the things that are happening in the industry, um, they're no longer just looking at this as like external communications in a container environment. They are fully expecting you to include additional things. So in the what's called an SSP data flow diagram, it's one of the control implementations that they're going to ask you for. They're going to need to see that the FIPS validated control module is in place. They'll also need to understand in your network where encryption is implemented but not FIPS validated, and also where encryption is not validated. So what we've seen is auditors can throw darts at these diagrams where they're not just asking you to show these configurations, but in some cases proving kind of the full scope of it as it relates to those things. So there's controls like SC13, CM06, which are very, very big requirements coming from these things. And obviously building with those things in mind means that your teams don't need to consider all the ins and outs of every type of Docker image that's in use in these environments. So that's pretty long-winded, but I don't know, Natalie, if you have anything you want to add to that.
No, that was perfect. Actually, I was gonna just mention that, this is not a technology that is new or novel to the federal government. A good example would be the $15 billion DoD enterprise data and analytics platform that is built on our images. And again, that was getting a mission critical app through ATO. So, implementing images, from us, they achieved impact level 5 and 6 in less than 8 weeks. So that was not a small move at all on the part of the government. But there's also private sector use as well. Eric, do you want to talk about this one a little bit?
Sure. Yeah. Snowflake, very large customer of ours. Obviously, any software provider that's looking to deliver their software in an authorized environment will need to pass their own FedRAMP requirements for these things. So the internal teams were trying to do this. I think they started in about 2023. Yeah, it says that in the slide. And then the cost of doing it slows down the progress. So initial configuration isn't always the issue, but it's kind of like, okay, what happens when we get that in place? How are we going to maintain this? How are we going to continue to maintain our authorization level past that? And I mean, looking at tens of thousands to hundreds of thousands of vulnerabilities becomes an intractable problem for humans to do, right? So if you're in the business of delivering software, you don't want to be in the business of playing whack-a-mole with CVEs to be able to deliver to that market. And I think that's where we got brought in to fix the CVE problem, where not only did we make a dent in that initial CVE count for the auditors, but we had a plan in place with the SLAs and the guarantees to say, look, like for ongoing Conmon, it could be as simple as saying, yep, no more CVEs in this environment, it's still at 0, or it could be, we've got 5 critical, but here's what we're doing to address it. And that goes back to kind of the signal versus noise ratio, where you're never going to eliminate CVE remediation or the need to have a program in place without chain guard. With or without chain guard, you need that security program. but making that more efficient so that in your Kanban, in your POAMs, in the things you have to present to these auditors, it's a lot more manageable of a body of work, right? You're not focused on this huge surface attack and all these things. You have the clear signal of what you need to do.
That's really cool. And hey, quick question. So Natalie, you had mentioned
Yeah.
the DoD example. So you're saying that customer was able to get an ATO in what was that, 8 weeks?
Yes.
That's really remarkable, Natalie, because all the
Yes.
time I hear about organizations, right, trying to implement software, and ATOs literally take months and sometimes even like close to a year to resolve all of the CVEs and all of the issues. So
Yes.
that's really, really impressive, especially, and that was at what level? Was that IL4, IL5 that was
Five and
accomplished?
six. That
Five and
was five,
six.
five and then six.
Wow. Yeah, that
Yeah.
that is really that's a great example in terms of, not only the ability for the DoD to have a solution that can impact mission, but from a software perspective, right, with 100,000 users, right, that enabled the provider of that software to recognize revenue so much faster and to drive usage and consumption, in a cloud model. So that's really a very remarkable example. Thanks for sharing that.
Absolutely. Thank you. And we have a lot of our best practices guides. Like there is no, we showed you what we do here. There really is no magic to that. So we have a best practices guide. We can include that in a follow up. Um,
Great. Great.
we're also able to meet you where your mission is. So your registry, wherever you need to be, we're able to meet you there. And we're not ever going to be a scanner. So we partner with any of the scanners that your government customer wants to use. So your Prisma, your Aqua, your Encore, your Wiz, etc. But we will not become one. We feel like it's a conflict of interest to say that we do things the right way, but only if we check our own homework here. Like we're not gonna be that person. So please give us all the scanners you can. And I think we have some questions.
Yeah, we sure do. And just to highlight, folks, I had mentioned the chat using that. It's actually there's a Q&A. If you on your screen, if you hit more, you'll get the option for Q&A, so you can send in questions through that. One of the first questions really is, the FedRAMP is such an important standard, right, for companies that are delivering a SaaS solution, because it's a requirement by every agency, and then in the DoD,
Yep.
as well as IL4 and IL5.
Yep.
How has the whole FedRAMP process kind of changed over the last couple of years? And then what do you expect? How do you expect it to change in the future?
Eric, do you want to jump in on that one?
Yeah, I think I mean there's so many different places you could go with that. The I think the main thing is like, and this might be my perspective, Natalie, you can gut check me on it, but I do think because containers are being adopted in such an accelerated way within organizations as the vehicle to deliver software and release product. I think if you look at like 142 and some of the requirements a year and a half ago, they're catching up with a lot of these things, right? A lot of it's an education thing, and a lot of it is getting more specific. Like, so if I had to highlight anything I'm seeing with our customers, it's that, what got you to pass an audit a year and a half ago might not fly this time around because there's increased scrutiny on how you're running containers, where you're delivering them, how they're accessing different types of sensitive information. And we're seeing that with 143, which is going to become the law of the land in 2026. A lot of people are asking about that. Some of the new changes that have come out in the last couple weeks. And I think one of the biggest questions organizations are asking is how do we keep up, right? Because it's constantly changing. So I think fundamentally the risk avoidance and the foundation of what you have to do stays the same, but everything's changing every month and every few months. And It's how do you accommodate that and maintain that over time as the industry kind of catches up with more specific requirements that are coming out. I don't know, Natalie, if you want to add anything, but
Yeah, I think that the bigger level, both on the like FISMA and FedRAMP side, but also on the DoD impact side, is at the end of the day, like all of these frameworks are around understanding the risk to mission data. So whether that, civilian missions or military missions, doesn't really matter. Like we're trying to understand and communicate that risk. And how this has changed over the years is really rather than just accepting risk and putting mitigating controls in place, the government, mission owners are asking us all to say, hey, like, do we really need to accept this much risk? Can you fix your stuff? And so having that pushback is, as a tax-paying American citizen, I feel a little bit better about accepting less risk and doing a little bit more hard work.
Great,
So
thanks. And just to clarify to the attendees, we'll actually use the chat for Q&A. For some people, the Q&A function is not working. So here's a question in the Q&A, and the question is, when you make these packages smaller, what exactly is being removed? Take something like GDAL used for image processing. If we're running with ChainGuard's version of GDAL, what features exactly do we have to do without? So I'll put that question over to you.
yep. I can talk about GDAL specifically, but Eric, do you want to talk about just general, like what gets removed?
yeah, definitely. I think so we're not necessarily we don't fork source code and change the underlying package. We build it from source and we package that. So we're not manipulating it at a code level. Like it's the exact same equivalent of what you would pull from upstream in terms of like the package or dependency. Where we minimize things is in the images, the container images that compile that are built with those packages, right? So like if you take an Ubuntu Noble base image, it's going to include tons of different packages you don't actually need and a ton of dependencies you don't need depending on the application you're running. So making specific images for that are purpose built and minimal to only include the packages and dependencies you need is that. So the goal is no feature removal, right? We're not gonna reinvent open source and build it ourselves, but we are going to build it from source and include it in a minimal way. Natalie, do you want to
Yeah,
go
and
off
I,
on that?
I can add some GDAL flavored color here. So what the way that we handle software that is very modular, like GDAL, is to have a base image, and then we have an ability for you to customize and add more plugins, more libraries, etc., to that image. Again, each version would be normally a little smaller. However, that's not always the case. You can make an image that we ship every bit as big by including all the things.
Yeah, it's a
So
little bit of like I think like if you look at like the trend since containers came out, obviously developers prefer give me everything, give me the kitchen sink, and then like the standard I think, and where we've hit a wall is that scanning has become so challenging because you're taking something big and you're trying to trim it down and you're trying to cut off things, right? And that will always result in kind of a zero-sum game, right? Like you can chase your tail going down that path of how to take something big and make it smaller. That's what big distro's done for years. Distroless, right, which is relatively a new concept, is the opposite approach, right? Start small and only add what you need, right? We prefer that approach because it's much more minimal. And then, yeah, it's Natalie's point. If you need these 5 extra packages, then just like any other normal app you're building on a Docker image, add those into it. But your starting point is a lot more secure versus trying to figure out what you don't need and what you do from a big source, right?
Great, thanks. That was helpful. So the next question I think is somewhat related, and I think we've talked about part of it. But let me just read the question and then we can take it from there. And the question is, do software packages ever lose some capabilities in order to maintain the low CVE count in such short SLA-bound resolution periods? And do the fixes for CVEs that you all make, ChainGuard makes, end up being propagated to the original projects?
I can I can take an initial stab at that
Yeah.
you want. So I love this question because we are not providing our own patches to remediate CVEs, and I'll caveat that in a minute with cases where we might. We believe that the upstream providers and the CVE disclosures are the best sources of analysis in the open source community for what has a fix and what doesn't. So because we pull from those things, what we're effectively doing most of the time is we're able to fast forward these fixes at a very detailed level, and we're able to test for breaking changes and dependencies, all the transient things that would require in that dependency bump to fix that. So like the way you would resolve a vulnerability is you would have to do all of that. You would say, okay, if I see a CVE fix for my scanner, if I upgrade that, what does that mean for my application? Well, our factory and our automation, Natalie said it's not magic, it's just hard work and automation. We're doing this. So we manage the packages, and we're building them into the images in a way at a very nano level where you can effectively deliver the resolutions to those version streams and those packages within different versions of the images, right? So one of the good things with that is if you're running Python 3.11, it's not that you have to be on the latest to resolve everything. It's just the state of distros in the industry is that generally speaking, upstream maintainers and distros do a better job at including fixes and LTS releases and newer versions, but they're very slow at updating it. Doesn't mean the fix isn't there and that it can't be included in 3.11. We are able to do those types of things where you don't have to be on the latest version, but we can deliver supported versions and things, and kind of get microscopic with those packages and those dependencies. For high load bearing things like glibc, our factory and the YAML file and everything that Natalie showed you earlier, we do have the ability to create our own patch, but it's not what we want to be in the business of doing. We don't want to fork code. We don't want to maintain our own testing on that. We'd rather take advantage of the broad set of info that's already out there. Anything you want to add, Natalie?
That's basically everything. Is in general, we try not to be in the business of carrying custom patches because that's what introduces the potential for a breaking change.
Yeah. The other part of that too is ChainGuard does a lot of the analysis. So we have our own security advisories that scanners integrate with. And so like one of the classic cases is take Strumzy Kafka or something where it's a very specific version stream of that third party package that's being developed. There are cases where we can't fix it, right? It might say, hey, Strumzy Kafka 4.5, this package is only fixed if you upgrade to 4.6. And we will be conscientious of that, and we'll post a security advisory that says, look, you might have this vulnerability in your image, but we're not going to bump this because it would break upstream, right? So it's kind of like there's a lot of scenarios you have to accommodate for. There's cases where we're not affected. There's cases where it is a false positive. There's cases where it just doesn't get included in a ChainGuard image because we don't use that component. But effectively, we're doing the CVE analysis so that when the image ends up in your registry, all that work's done up front and you have an explanation. So for POAMs, that's really important, right? Because you might have a CVE that you have to provide an explanation for. Well, we've done that analysis, right? And so you have literally a copy and paste analysis from the advisory that says, hey, upstream depends on version X. We can't fix this until it does it. Great. Exception accepted, move on, right? But you don't have to do a lot of that third party open source analysis. We do that for you.
Excellent, thanks. So let's talk about one more topic here, and that's really encryption, right? And a lot of the firms that are in the In-Q-Tel portfolio are relatively new to government. And I know that FIPS, when I was a software developer or leading software teams, right, there was always a discussion around, hey, do we really need FIPS? Then this 140-2 and use certain libraries. I think it'd be good for a minute just to explain kind of the government's requirements around FIPS, and then also what you expect will be happening with the latest version of FIPS, which is 140-3, and how that, how companies can kind of prepare both for including FIPS in their products for encryption, as well as how to prepare for the future.
Sure. So I can jump in for a little bit on just the cryptographic basics. So what FIPS 140 is it is the Federal Information Processing Standard. There's a whole lot of them. What information is considered high impact? How to run a fax machine is actually a FIPS standard. There are many of them. FIPS 140 is specific to cryptography. So information security, being able to say that Alice and Bob can communicate without Charlie listening in. And what this standard does is a couple of things. The first thing is it says these minimum standards for what can and cannot be used. So everything from how you hash a file to how you encrypt that data. The real nuts and bolts of information security goes into that standard. And part of that is you must have those cryptographic methods looked at and basically peer reviewed by the government. I'm normally pretty good at maintaining my bearing, but apparently today is not the good day. And that process does take time. You get in queue with a program at NIST to have that code validated. And so that is going to be both tested and peer reviewed, and that costs time and money. Validated cryptography is critical to mission security. And what I mean by that is cryptography is one of those foundations of the confidentiality of information. And that is why FedRAMP, but also any other mission standard says like, hey, we need to do this. Cryptography is hard work. It's hard mathematically, but it's also hard to implement correctly. And there's a lot of different ways that you can implement it. What looks correct and actually ends up being quite not correct. So the rules have been that you must have a FIPS validated module. And there's a new revision that's changed which algorithms are correct or allowed and which ones are not. And that's that move from 140-2 to the upcoming move to 140-3. Eric, did you want to jump in here?
Yeah, I'll just add like 30 seconds because I know we're broaching time, but no, you covered it perfectly, right? The main thing is one, the correct cryptography is in use, and then two, it's configured correctly, right? And proof points around that. But like to Natalie's point, it includes data at rest. It includes things like storage backups, media drives, everything you can possibly think of to like, personal identity verification credentials, who has access to what. As it relates to containers, it's a little simpler, right? Is your application on a container image using a valid FIPS module from OpenSSL or Bouncy Castle, for example? Is it configured in approved mode only so that when cryptographic operations happen, it's only using those things? And can you show that to an auditor, right? And we've pre-configured all of that in our images so you don't have to do it. One of the other things is entropy, and it's the last thing I want to touch on. Host entropy, the SB 900 B requirement means you need an entropy source on your nodes or your operating system you're running your applications on. That basically randomizes things, and you need some entropy source. We ship that directly in the image, meaning you can run and pass an audit without worrying about hardening your hosts for FIPS. So that's a really interesting thing. Anyway, that was more than 30 seconds. I can never fit within 30 seconds, so sorry.
Okay. That's okay. So hey, one last question popped in that says, I may have misheard, but earlier I thought I heard it Natalie mentioned something about not pulling in entire packages or excluding unused parts of packages. Does ChainGuard does the ChainGuard build process do some sort of tree shaking or other processes to slim down dependency sizes or prevent double imports? So a lot there, but
Yeah,
maybe we can have that as our last question.
yeah, there's a lot there. No, we are not doing tree shaking or slimming. There's a couple reasons for that. The first is in order to understand the software you're running in production, you can't mess with that software by just ripping out parts of it. Fundamentally, that breaks how scanners work, and that typically breaks how a software bill of material works. So if you have a package that says needs these 8 files and you remove 3 of them because they're not in use, are you still vulnerable to whatever data or whatever vulnerabilities that would
Yeah.
be in that? And the answer is you don't rightly know. Now you need to
Yeah.
go way deeper in order to
Yeah.
answer those questions.
Yeah, and that's the whole, like, going back to the industry term or definition of hardening. If you're ripping things out, what you're really doing is you're not resolving these things, you're decreasing surface attack. And that's one part of the problem, right? And there's a lot of vendors out there, distribution, scanners, optimizers, if you will, that are doing that. But to Natalie's point, a scanner picks up on package manager metadata, and very much like the source of how those packages get built. Just because you remove a few files doesn't mean, I've seen cases where there's 27,000 shadow files of those packages that are still vulnerable. Your scanner would never tell you that. So you're masking the problem if you take things out, right? I think that's an important point and why we built our own OS.
Great. Well, terrific. With that, we're coming up to time. Eric and Natalie, thank you very much for your time today and sharing your great insights and experience. Right, the title of this webinar today was about how to accelerate your ATO. I think you shared a really compelling example about how ChainGuard helped get in an ATO in literally 8 weeks for a DoD system that had 100,000 users, and that was both on unclassified and classified networks. And that's a very, very compelling, as opposed to the many months that I hear from other firms that it takes to get an ATO. So thank you for sharing that. I think also sharing that example about how Snowflake, which is a very innovative and large provider of data management, was able to use ChainGuard to accelerate their FedRAMP process, I think was also a really excellent example. So with that, I'd like to thank everyone that attended today. In a few days, we'll be sending out a copy of the recording on a YouTube link, and we'll also be including some information about ChainGuard and how to get in touch with them for further questions. So with that, thank you very much, and we look forward to our next webinar, which will be coming in September. So thanks again, everyone. Have a great day.
Thanks, everybody. Have a good week.
Thank you.
Thank you.